Good afternoon. First of all, I want to say thank you for this nice invitation and this opportunity to be in Singapore. I'm really impressed by what I experience here, and I think thank you for the organizers of the conference. They're doing a great job, and I'm a little bit asked to talk about the values of architecture and for 21st century. So mainly when I talk about architecture and the future, there are three important things in my back you should know, what we believe in very strongly. So a lot of things I will tell you only make sense in relation to these thinkings and beliefings. The first one is that we try to work for a middle-class orientated society. Middle-class orientated society for us means that it's focusing on about 80% of the population. We know there are 10% which are much more rich, and there are 10% which are much more poor. This kind of believing is very much related to Europe at this moment, and I know that there are different strategies to deal with the understanding of a society. Nevertheless, living in the middle of Europe, we stress very much on this believing. What I have to say in addition to this, when at ETH I do a lot of research about the quality of architecture. We developed during the last 15 years some methods, what we call evaluation. And these evaluations, we do it like this, that we check projects when they were designed, when they were built, 5 years later, 10 years later, 15 years later, so to know more reasonable what happens really in our built environment. And out of this, we recognized two very funny things. The first thing is that architectural design is never used by the clients in the way architects have been thinking. That's a very nice thing, I think, for architects, so they should not they should not take all the marketing ideas serious. To do architecture, sure, they are important to develop a project, but nevertheless, in a long-term view, these ideas will be adapted and change themselves during the lifetime of the building. The second one, what I think is a result of a very European experience. Nowadays, especially in Europe, we talk a lot about the issue of more sustainable development, because we recognize that the developments of our society came up to limits where the development became fragile, where the future is not that clear anymore, and a little bit we were used to believe in the things which were established during the last 50 years. Why do I speak about Europe and the last 50 years? You should consider that in Europe, 65% of all the building stock has been developed only between 1950 and 1980. So this is real Europe. It was built after the Second World War between 1950 and 1980. And the second issue is that in this building stock, about 65% of the building stock is only related to housing, and about 20% is related to offices, and some very small percentage is related to industry, and only a very small percentage is related to churches, museums, sports stadium, sports facilities, and things like this. So in the end, when we do research, we always find out that people are very much determined when you ask them about their quality of environment, not by the 3% which are left, but by the 90% of buildings which they have to deal with in their everyday life. I always say it in more simple words. There is architecture for Sundays, and there is architecture for working days. On Sunday, you go to the museum, you go to the sports, you go to churches, you go to political manifestations and things like that. Doesn't matter. But nevertheless, Sundays have to be very different than working days. And in our architectural discussion, what I recognized also here, sometimes we mix up. We have the believing that the Sundays determine the working days. In our experience, I say no, in the quality of living, the everyday places become much more important than only the places for Sundays. But at this moment, we don't have clear strategies on which area we really behave how, or on which area we really use which kind of methods or strategies to do design. So nevertheless, during the next 30 minutes, I'll try to talk more about everyday architecture and not so much focusing on Sunday architecture. Maybe you don't like the word, but Sunday and working day is very simple, you know. I think that's a little bit what I talked about. The next issue, what is so out of these discussions, and especially out of this very strange European experience, that 65% of Europe was built only within 30 years. And when we talk about the experience, what we have nowadays with this building stock, it's very complicated. Because this building stock is maybe the worst one we ever built during our history. And the social and cultural importance of this building stock is mainly discussed. So at this moment, we tear down a lot of buildings out of this period and try to replace them, reorganize them, adapt them, or whatever. And this kind of tearing down buildings which are only 30 years old or maybe 40 years is a strategy which I think is not very reasonable to manage the future. But nevertheless, why did this happen? That's a question we were dealing with a lot of time. Why does this happen? And mainly, I think there are two backgrounds which made it happen. First, the first background, and maybe the most important one, is that when this building stock was built, we had clear ideas about how society should be organized. We had ideas about family, about working space, about the relation of these different things, how to spend our leisure time and things like this. But the development showed us that society changed dramatically. And the values which were implemented in these buildings, they are not here anymore. I will give you some very simple example about this issue. For example, in 1970 in Europe, the percentage of people living in family was about 70%. Nowadays, it's lower than 40%. So the majority of Europeans don't live in families anymore. But all the housing which was built during this period was determined to be used by families. But the needs and the necessities and the desire of our people nowadays, they are very different because they live in a different kind of social organization. The values of society changed a lot. And so when we bring together the changing demand of our times of society in relation to the building stock, I think we did a big mistake. We did a big mistake related to the idea that architecture is determined by the program of the building. And that's the theory of the 20th century, which made the 20th century so successful. But especially when we speak about more long-lasting developments, to have this idea that we should have different methods to tackle, to build up our built environment than we were used to. That's one of the big questions as a result of these changing times, you know. So, you know that I think nobody likes to tear down buildings after 30 years, especially when you have examples of buildings which will last 400, 500, 300 years out of European history. And then you start to ask yourself, what were the qualities of these buildings which give them such a long life? And what were the missing qualities which forces you to tear them down? You can also imagine that this building, to tear them down at the moment, is a problem in economic terms, in ecological terms, in resource terms. It's a big problem, nevertheless. So the one architectural answer, and I think that will be very important for the future, is that when we talk about building in the future, we will have to talk about new time frames. Now we are used to think about maybe a building of 20 years or 30 years, as long as the use is determined by our now understanding. But the building itself nowadays by law has to guarantee to be consistent for more than 100 years. And so the question will be, how do we deal with, and what kind of new questions of production methods, of technologies, of architectural understanding do we develop when we want to develop buildings which have a long lifetime? And to have been, you know, maybe that about I know some numbers, you know, that for example in a city like Hong Kong, 92% of all the energy at the moment is only determined by doing buildings and maintenance buildings. In Europe, in average, it's about 60 to 65%. In the United States, it's about 70% at this moment. And so when we all agree that there is an somehow ending capacity of resources on our planets, and it's not only about energy, it's also about materials, it's a lot of different things, then we should understand maybe we cannot go on like this, but we will have to adapt our thinkings in this. And at this moment, one of the most easy way to adapt our thinking is that in the building, you know, you divide between gray energy, that's the energy you have to put into the construction of a building, and the maintenance energy, and normally the gray energy is about 1/3 of all the building will consume in all its lifetime. So when you give a longer lifetime to the buildings, that's one of the biggest contribution architecture can do to manage the resource problems on our planet in future. And the third one, what I also would like to talk about, is what is also part of our very simple thinking, that somehow we live in a time frame or at a period where we have to start, you know, in the 20th century we were used to think about quantities very much, you know, higher, bigger, more, longer, and things like this. But I will give you two very simple numbers. The average lifetime in 1910 in Zurich, so very well-developed city in Zurich, was only 40 years. The average lifetime now is about 82. So we doubled only within 100 years. This has a lot to do with the quality of the built environment. You know, that's all the people from healthcare will tell them, that the quality of the built environment is more important for the lifetime than the medical treatment. But nevertheless, but can you imagine that people will become 160 years, 100 years later? I cannot imagine. You know, I give you another number which is also very simple. In 1910 in Zurich, we had about a built area per capita in housing of about 9 square meters, overall of about 16 square meters. Nowadays, we have a built area of about 52 square meters in housing and about 89 square meters overall. So when we would do the same calculation for the next 100 years, it would mean that we have to consume 380 square meters of housing per capita and about 550 square meters overall. I think nobody can imagine. So at a certain moment, even if this 20th century was so successful in producing quantities, somehow we recognize that this cannot go on like this for another 100 years. So at this moment, I think, I know that this is a very European experience, you know, so I never would say that there is not a lot of quantity, necessity in a lot of developing countries, but nevertheless, for example, the United States, they have a similar problem. You know, so, but when you ask you these questions, so the only, now what we are talking about in architecture is not anymore quantity. It does not make sense to do everything bigger, wider, higher, low, but we will have to generate new values for dealing for the future. So, and that's a little, so I always say in general, the changes in European history at the beginning of the 19th century, when Europe became, as a result, an industrialized societies, nowadays the changing to become a service-orientated society has much more impact on the built environment than at the 110 years ago at the beginning of the 20th century. But nevertheless, I think I only want to say in very short, we try to adapt from quantity thinking to quality-orientated thinking. And all the time when we ask ourselves what means quality, and when we try to do research about this very stupid word, we always find out we don't know that much. We only know what we are used to. But when we are really asked to describe very clear what would be quality besides the dimension, the quantity, it's a very complicated issue. So another thing is, you know, when for us it is very important in design for every project to have a clear goal. What is the goal? And according to this goal, you will have to deal with a lot of different issues which will determine your methods or your way how to do design. So for example, a strategy to create a building with a low operation cost is a very simple goal, because you only have to deal with 4 issues. You have to understand your climate. Until now, a big problem. I always recognize that we architects or the people involved don't really understand climate. We have to talk about comfort, because what kind of comfort do we really want? What we are used to, we know, but is this enough? Or is it not enough? Then there is another, when you have these 2 basic understandings, you can ask how you can optimize your building and how you can afterwards use the technical systems to sozusagen do some further contribution to this goal. So in the end, we always talk about strategies related to the goals we will have in the development of a project. I show you another goal. When you want to create a long-lasting, efficient building, then the possibilities and the influences become immediately much more important. But what is important when you speak about long-lasting and efficiency, then immediately the local backgrounds in social, cultural terms become much more important. And to understand them, sometimes very complicated, and then you have a lot of different possibilities how to answer them. So the next one, and I think that's a little bit the big task in our planet at the moment. How do you create long-lasting settlements, for a big scale of people, for a big amount of people? And then you really have to understand that this is to be understood on an individual level, on a social level, on an environmental level. And out of these understandings, we think that there are three important questions for developing architecture in future. One is densifying, the other one is open building, and the third one is resource efficiency. And I want to talk very shortly about these three different issues because I believe they will determine future architecture in the same way as the understanding of program and technology determined architecture of the 20th century and what we do at this moment. So the question will be how much of the knowledge and of the skills and of the abilities, of the methods we can adapt for the future development when we clarify in our minds the goal, what we will have to do. So first I want to talk a little bit about densifying. When I speak about densifying, I do not think that there is one density which is optimum. So there are different densities, and so therefore, at this moment, I'm always asking myself, what were the reasons why people decided to settle in different kind of geometrical organization? You see some of the patterns, some of the cities, yourself, I don't want to comment. The city I like most is the most strange one, because you see on the right down at the left side, there is Barcelona, and Barcelona is the European city which is very different than all other cities, because the grid is much smaller and the buildings are much higher. And that's not European, very strange, but it's another issue I don't want to talk about. You see in the overlapping of the cities, there is always the same space what we need for a highway crossing. You see, I hope you can see on the images. And then you see that's something which maybe is for the future development very important, that at this moment we use mainly the same area for transportation, for mobility, than we use for settlements. Also, this is a big question. Will this really be the future? I don't believe, but nevertheless, when you don't overlap this, you don't believe how big is a highway crossing, in reality. So, but nevertheless, okay. So we did a study, which is, first of all, we were focusing very much on European cities, so we have chosen 4. That's Zurich, Munich, Vienna, and Berlin. We were very unsure about this, And then we categorized the cities into different districts and calculated the density in a very simple method that we calculated how much area above ground is built in relation to the ground. They are different. In every country, it's a little bit different how you calculate this, but more or less. And what we tried to find out, are there certain relations only determined by the density? So, or to say it more stupid, is the main question of architecture is to choose the density. Because what we find out at this, and I will show you how we did it. We know density calculations in a, sorry? Oh yes. We know density calculations normally in mathematical terms. But what we were interested in this very simple question, is there a relation between the density, the land use area, the atmosphere, social impacts, how people live together, how they relate to each other, how much do they like it, how much rent or price do they pay for it, and what's the quality. So we did we used a lot of different instruments to do this quality-orientated research. We sent photographers for all the 40 places. We sent architectural journalists for all the 40 places. We did a lot of interviews in all the 40 places. We got the numbers from police, how much people move in and out. We got the social background of the people who lived in this area. So, and then we started, I do it very fast now. You see, this is all about these different categories, and we did this for 40 districts. Okay, some of them. You see, we didn't care if they are old or new, or it doesn't matter, you know. And then we did profiles for every district, and then we started to overlap the profiles. And then we found out that there is some very nice things I didn't know before. For example, that the density characteristics is mainly related to the values of a society. So they are changed within periods, but they have a long, reasonable, according to the slow changing of the values in the society, they stay quite stable for a long. And then we also found out good areas, they are over a density. Good in the sense, as I documented before, they're only over an area which are very high or very low. But the problem is that, for example, most of the developments in Europe, which determined Europe between 1950 and 1960, they were in between. And that's a little bit what you experience in Europe, that the big parts of the cities, they don't develop very high qualities, especially those who were built during these periods. Then we also found out that the acceptance to pay about the price is related to density. The fluctuation, how often people move in and out, is related to density. And out of these studies, we also found out that the quality of the public area is the key issue if houses are accepted, well treated or not. And we also found out that you find very good high quality areas, high quality public areas, only in densities which are much higher than what we did during the last 50 years. And okay, so nowadays I do not want to talk in detail about all these different things, but nowadays we know a little bit more how the relation of density and the social, cultural impacts and qualities are only based on this density. What was also very funny, even if, you know, we had a lot of different architectural styles represented in these different districts, the architectural style did not influence the quality that much. It was only the land use area. And there is also another thing which was very interesting. The higher the quality of a development should be, the higher the percentage of public land is needed. We all knew these numbers, not exactly in advance, but this was very interesting for us to understand the European city. I know this is a very European-orientated analysis, but at this moment we started to do the same way of analyzing for Asian cities at Hong Kong University. This was one of the reasons I had been there before I came here. And I hope within 1.5 years we will have maybe similar knowledge about Asian cities, what has been developed during but we didn't check until now. But that's nevertheless. Then the next big question, what we are dealing is that I told you we call this open buildings, which means the lifetime of a building should last much longer than the use of a building. You know, the normal use of a building is not more than about 1 generation. That's about, it depends, 20 years, 25 years. but the building quality, the building stays there for much longer. And so how do we deal with this question? And we did in Europe a big mistake that we fixed somehow by using concrete and solid walls the future of the buildings. But this ended up in a big mistake because we recognized that people want to live different from generation to generation, that they work very different from generation to generation, that they teach very different from generation and generation, and things like this. For example, at this moment in Europe, we have a very big issue that all schools, they change their teaching methods. But this means that most of all schools have to be built new. So that's a little bit only one thing we recognized. So out of this, there's a movement in the world called open building. It was founded by John Habraken. It's a Dutch architect which was teaching in Cambridge quite long, and he did, out of very specific reasons, he developed this idea of the open buildings in relation to an open society very early. I only show you some examples where we try to put this into practice. This is a very simple way of open building. For example, in this building, you see there are workshops, there are office places, there is some kind of business, but all the building has the same quality in relation to room height, in relation to surfaces, in relation to technical implementation. And so we were very glad that we could manage that in this building there is no difference anymore between blue-collar jobs and white-collar jobs, whatever people do there. And we appreciate this a lot, also for the future of the building. The next one, what you can see in the very simple layout of the building, is that in all open buildings we try to use as big spans as possible. We always prefer to have that's a very simple issue. So nowadays we are used, according to concrete or steel structure, spans of 7 meters, 6 meters, 5 meters. We think that's a wrong development. We think the spans should be much higher, and then you see, that's only one example of this build. You see, that's, for example, the separation of the workshops in the back and the office spaces in front. That's the way of interpretation, this open space. The depth of the building is quite high. It's about 20 meters, and the span is about 18 meters in depth. Okay, another issue, and that's I'm sorry I have to fasten up, but I want to tell you this story. The client of this story is the client of this project is a director of one of the very important Dutch cooperatives. So they were founded more than 100 years ago, and they own more than 30,000 apartments. So and at the end of his career, this director, Mr. Biedendijk, came to me and said, I want to do one building which gives a nice future to my cooperative. Because a cooperative, it's a very traditional way of organization in real estate. And he said, first, the only thing I'm not interested is the program of the building. So please do a building, there is no program. Second, I want to make it possible that whoever wants to use the building, he is allowed to use the building, and that he was very radical in this sense. He rented the building out on eBay. So I said, I don't want to talk to anybody what he needs or what he wants. I do the things I believe in, and afterwards I put it on eBay, and everybody can say, I pay for floor number 6 for 200 square meters on the right, €6 or €10 or €12 and things like this. So everybody was a little bit, you see, I like this layout. It's only about stairs and facades, and there's big spans, more than 11 meters. room heights more than 3 meters and 60 in average. So the free room height is, the concrete is about very thick according to acoustics, so that everybody is free to do whatever he likes. You know, and you see, okay, that's another issue. But for me, this to generate the address, the public space, how you come to a building becomes so important. And you know, that's the way how you rent the area. It's empty. And then you can decide yourself, how do you organize, how do you manage? And all the technical support of the building has to be organized within the core. So you decide from the door entrance up to the end of the building, whatever you like to do. And I only want to tell you the story very fast. In the end, there is in the building rented out by eBay, there is a Montessori kindergarten at the 2nd floor. There are social housing apartments. There is a private hotel of 16 rooms, which is very small, on the corner over the watch. And there is the representation of the biggest American office furniture company on the ground floor, you know. So there are doctors and lawyers and some architects. And so a lot of people like to get an empty space and then organize themselves. And you know, you can imagine that this strategy was in economic terms very successful, you know. But it's a lot of risk, you know, to do this kind of development very fast. So, but I have to fast now. Another issue, what is also very funny, is a hospital in Belgium. This is 1,400 beds. No. And you know, when I was doing this project, I've always been thinking, first of all, I do not want to have a high building, you know, because people don't like high buildings, especially when they live normally in small-scale buildings, you know. Second was, how do you organize a building that it's really big? It's about 1.8 million square feet, so it's really big. Then how do you organize? And how does healthcare work in 10 years? Nobody knows, because it changes dramatically according to technological development very fast. So I always ask myself, what can be parts of the building? Maybe it will be a gym or a school or a university or a hotel. And what are the conditions you have to generate within the building that this can happen? At this moment, the demand is so big that they go on building and the project is now too big anyway, it's growing, but you can imagine in this informal shape I showed you before, the growing of the complex is a very easy thing to do, you know. So, but it's, okay, I do not want to tell, but you know, in medical terms, it's very funny. At this moment, we are used that we as patients go to the treatment, you know, to the doctor, to the hospital. But a lot of people in healthcare believe that in future, you will stay at home and the treatment will come to you. But when the treatment will come to you, you don't need stupid buildings that big anymore. So it's a funny issue, but I'm very sure that maybe in 15 years, they only will use part of this area as a hospital and all the rest will be something else. I do not want to... you know, therefore, we were very much dealing with some very simple questions. Again, room heights, again, big spans, again, natural light. Also normal in a hospital, you have a lot of areas which have no natural light. People don't like it all, but nevertheless. Okay, you see, that's the service level of the hospital. Okay, sorry, I have to go on. This is a similar building in Amsterdam. And this is a building which is a very similar problem. That's the new university in Luxembourg, which is placed on a site of an old steel factory. And also there you have the same problems, except the big teaching rooms. This is finished in about 6 months. Okay, sorry, I have to apologize. But I could show you a lot of typologies which we were dealing with doing this question. So only have a few minutes left. I want to come back to my favorite thing I'm dealing a lot with, that's resource efficiency. And this is a normal diagram. What you see, the green line is the normal outside temperature in my hometown where I live through 1 year. Then you see the white line is the temperature will be generated in this area. And then normally, when you're an engineer, you're looking here and over here. You see the gray area is the area of comfort in relation to temperature where you want to balance the building. But you see this one and this, when you're an engineer, you're looking here, then you know how big your machinery should be to implement. When you're an architect, I'm always looking here, because there everything is fine and you don't have to do anything. That's a little bit my architectural dream, Everything is fine, you don't have to care. That's real comfort, You can interfere, but you don't have to care. That's comfort. So we tried, that's what we try to do in our buildings, that we try to optimize the period where the building sustains itself, only managing its relation to the outside in relation to the inside. Many years ago, in the 90s, we did research. I like to do experiments. So we did also, this is the biggest I ever have done. We built 3 buildings, one according to standards, one optimized to what is asked nowadays, to optimize the envelope of a building in U value, G value, and things like this. And one is the same optimization of this one. And additionally, you have all this new technology, what we talk about nowadays. You have some heat recovery, you have heat exchange, you have some earth, you have some heat pumps, all those things we do nowadays. Now it's very simple. And the funny result was, after 10 years, and we had measurements for more than 10 years in use, that the middle one was the most efficient building and the most well-accepted building. And it was not this one and not this one. But sorry for just going on. This is the ETH building, another funny story, because in a university building in Switzerland, it's very nice to be a professor. When you come there, you get an empty space and then you're allowed to arrange your space. And normally this cost is very high at every university because there's a strict relation between the technology of the building for heating, cooling, ventilation, lighting, and the organization of space. So in this building, you can change walls within 1 day because nothing is related anymore to the dimension of your room. And even lighting is not anymore involved in any walls or something like this. So this is it's a real high-tech building, and you see that's the inner space of the building. That's the whole facade is only done in this way. The geometry of the facade is determined by the sun. So we try to optimize that from the 28th of April until end of October, no direct sun will ever touch one sheet of glass, because heating problem is much more complicated than, cooling problem is much more complicated than heating problem. So you see, that's I like this space a lot because this is a student's lounge, but in reality it's the main lecture hall of this building. But normally, in the development of universities, lectures will become less and less important, and teaching in small groups, in studios and things like this will become much more important. Therefore, in very modern universities, you don't need lecture halls anymore, very seldom. So sometimes they can close it, and then this is the lecture hall. And the coloring of all the this is a project we developed in Beijing, also at the same goal. This was the first building in China which really used the most modern technologies in 2002. Yes. Oh, sorry, I have to go forward. The more I was dealing with this issue, the more I was interested in very simple questions. How can you do a building without any technology? And this is the first building I did without any technology. It's a very small building. And in this building, you cannot use this building all the year. But maybe you can use it about 300 to 320 days a year. Some days are too cold there, you know, not too warm, but too cold. According to height, not too warm, not too cold. But at this moment, we are very fascinated by this idea. How can we manage the relationship of the building to the surrounding? Not anymore by using a lot of hardware, I call this, but only by using more intelligence, more software, to make the buildings much more clever. That's a little bit what we tried. Okay, and at this moment, this is the last project I will show you. We did an office building. It's not that big. It's about 40,000 square feet. And we built ourselves for ourselves because this is the first building in Europe, no heating, no cooling, no mechanical ventilation, and we still guarantee not less than 22, not more than 26 degrees. We moved into the building in end of June. All people were very surprised by the temperature level. This is the main element of the building. This is the window, and you see this is in open position. Oh, sorry. Okay, you only see it in open position. So what's the idea? The idea is very simple. That in the end, nowadays, when you do a very comfortable, technically suitable building, then the building will only react very, very slowly, very small in relation to his environment, because it will be very stable. And but this you only have to do in very high technical quality, you know. But then the building will stay in temperature very, very stable. And you know, your losses are winds are only related to transmission. What happens on both sides of a wall, and the U value and the geometry, the percentage of openings and things like that. And this is what we know how to do according to the development of in a lot of climates all over the world. When you increase the build quality of the building will stay very stable in temperature. So the coldest period in the building will be end of March, not in January, not in February when you have a lot of snow there, but end of March. But so the other hand is that, on the other hand, for the energy demand, we need a lot of oxygen. That's for us humans the most important thing. So the building does something very simple. The building only reacts onto the impacts you as a user leave in the building. Mainly there are three impacts. You increase normally the temperature by yourself. You have 80 watt, if you want or not. When you don't want them anymore, you have to kill yourself. Until then, you have 80 watt. Second is that you produce humidity. Your body does for you. And the third is you transfer oxygen to carbon dioxide. So you produce a lot of carbon dioxide. And only if these elements are not balanced well, you don't feel well. So if there are two people in a building or in a room or 15, it's a big difference. But the building does not, you don't, as a user, you don't react to the building anymore, but the building reacts onto you. So what we do is we measure your impacts, and then we develop quite a complicated software to determine the behavior of the building. Okay, that's, you see some images of this building. It's in use now for 3 months, so end of the year we will have 1 month. For people it is very strange to experience that they always feel comfortable not doing anything. That's a little bit my idea of comfort, you know, to be able to do something, but you don't have to, you know. Okay. And, you know, I show you this image only because in the area I come from the mountains. There's a tremendous quality of craftsmanship, you know. And these are the standard tables in the office. And this is done without any glue, without any screw. It's only massive wood. How to bring the things together. But it's okay, that's another story. So, that's the end of my presentation. Thank you very much. I've been too long.